In today's video, we will give an overview of the setup, testing, and documentation of a hydrostatic pressure test for filter housing manufacturing. A hydrostatic pressure test is performed to ensure the quality of a pressure vessel's fabrication. It ensures the assembly can handle the fluid pressure it is intended for without leaking. In this application, these filter housings will be tested to 1.5 times their MAWP, or maximum allowable working pressure. This designation must be accompanied by the temperature at which this rating is given. For these filters, it is 72 degrees Fahrenheit. The test is started by sealing off all but 2 fluid ports. Install blind flanges, plugs, valves, etc., following the manufacturer's installation instructions or best practices. The water inlet connection should be placed as low as possible on the housing. Likewise, the air release valve should be placed as high as possible. A manual hand pump is installed in line between a pressurized water source and a vessel under test. In this case, the supply is city water at 60 psi. The gauge on the pump should be carefully selected to match the test's required pressure while still maintaining the resolution needed to detect a pressure drop. For this vessel, the MAWP is 150 psi, so we will be testing at 225 psi. This gauge can read a maximum pressure of 250 psi. Please be sure to use an NIST traceable gauge for certified tests. Begin by filling the vessel with water from the supply, ensuring that the air release port at the top of the vessel is open to atmosphere. Fill the vessel until water continuously flows from the air release port. To keep spillage minimized, a hose from the air release port can be routed to a bucket to collect expelled water. It is very important to get all the air out of the vessel. Trapped air pockets are compressible, and they will give inaccurate pressure readings as well as not leak check the surfaces where they exist. Before charging the vessel to the test pressure, dry off the entire outside surface from any spilled water. This way, any new water drops detected after pressurizing came through as the result of a leak. The manual hand pump consists of a hand-actuated piston and arrangement of check valves. It increases the outlet water pressure while not allowing pressure to flow backwards to the source. The system is charged by the pump to the test pressure. In this, it is 225 psi. For the test to be successful, no measurable pressure drop should be detected after a 10-minute pressure check. After the test concludes, the pressure should be reduced to the MAWP, 150 psi in this case, then held for another 10 minutes. A successful test means no leaks have been detected. Unlike their steel counterparts, a plastic vessel will expand when pressurized. Termed relaxing, the pressure read will be less than the test pressure the vessel was originally charged to. The pressure will stabilize, and no measurable change or weeps should be seen during or after the 10-minute test. Once the pressure is reduced back to MAWP, the gauge pressure will increase slightly as the plastic contracts back to its normal shape. After the test, the supply line to the hand pump is turned off. The air release vent is cracked, allowing the pressurized vessel to return to atmospheric pressure. Because water is incompressible at relatively low pressures, there is no risk of explosive force when releasing the pressure. If you'd like to learn more about Sigma or have any inquiries about a project we can help with, please call us today at 732-629-755, or you can email us at info@sigmadesign.net.